Hello, everybody. I hope you're all doing fine. Nice. Today, I'd like to welcome you all to our next show today. It's called United States of Flutter, and we'll talk about the unidirectional data flow concept today. We'll actually introduce to you, or the speakers will introduce to you several libraries which implement this pattern or this concept. And the first speaker, who I like to introduce to you, is Jeroen Meijer, called Jay, aka Jay. So welcome to the show. I'd like to introduce you, like, in a few words to the audience. Jay, you work as a freelance developer for Very Good Ventures. That's right.
Yeah, that's
so
right.
That's actually also the link to Felix, who we had in our last recorded show. So that's great to have two of you here in the show. You're also a Google developer expert for Flutter and Dart. So the right guy to ask when we have like Flutter or Dart questions. So that's great.
Thank you.
And you're the admin and maintainer of the Flutter community.
Right.
Can you just give us a little insight, or for those who are not familiar with the Flutter community, could you just drop a few words about what the Flutter community is?
Sure. So the Flutter community is a lot of things. Mainly, it's an organization, a group of people led by me and a whole bunch of other great people, where we try to bring the best of what the community around Flutter has to offer into consolidated places. So that means that we have a GitHub, which is specifically the part that I manage, where we try to collect all these great packages from the Flutter community into one place, make sure that there are always maintainers, there are always people that keep them up to date, and so those packages don't die out and are set to a certain standard of quality. Then there's the Medium, where we aggregate articles from all over the community and try to keep them to a certain standard as well. I believe we have one article out a day at this point, and there's a lot still coming. So yeah, we try to take what the community has to offer and put it into one sort of place and keep it up to a certain standard where people can get the best that is out there in one place. That's sort of what it's like.
Very cool. Thank you. Thank you also for giving us all ideas which come from the community, like a structure, and prepare it well that everybody can use it. Today we talk about states, as I said, not about the states, but the states which we all deal with in our applications, more specifically in the Flutter applications right now. In your talk, you'll introduce us to this concept called Unidirectional Data Flow and some libraries or packages which implement the concept. So I would like just to hand you over the mic, or to give the stage up to you. Take it away.
Cool. So can you all see this slide?
Yes.
Okay, perfect. Well, thank you, everybody. So I'm going to be talking about unidirectional data flow and why it rocks, and introduce Redux, qubits, and blocks. And yes, I'm very proud of that title. It's a little bit dense, but I'm going to try to do my best to sort of introduce the concept in my sort of fashion, and then lead you through it and show some packages that use it. So first off, a little introduction about myself again. I'm Jay, a Flutter community admin, a Flutter GDE, and I do a bunch of open source stuff, and I work at Very Good Ventures, but I also do freelance stuff for other people. And so, yeah, it's very nice to meet you all. And if you have questions, I'd love to see them in chat, or you can message me later on, or visit my website, whatever you want. So let's talk about state management. What a fun topic in the Flutter community, isn't it? This is very heated. It's always, it's not been heated. It's more, it's very divisive. There are a lot of different opinions out there. There are a lot of frameworks. There's a lot of different approaches, and the list goes on and on and on. So I want to just get down to the basics and introduce you to sort of one way of doing state management within Flutter specifically. Now, first off, what I think it's important to note is that state management is fine if it's small, if it's local. You don't need to use a package or anything, right? If your state is easy to to use, or it's small and it's concise and it's a small application, the scope isn't large, right? Use something that's built in, right? Use change notifiers, value notifiers, use patterns like inherited widget, use whatever the framework provides you if that's enough, right? You don't need to go overboard. So yeah, keeping state local and passing it around for like tiny applications or small utility things, that's totally fine. I wouldn't write a calculator app using, MobX or Redux or whatever, right? Because it's tiny. However, there is some truth to the fact that if as soon as your app grows, then you might want to adopt some sort of state management pattern to make your life a little bit easier and keep your application more concise and controlled. So that's what I'm going to be focusing on today. And one sort of design pattern that a lot of these state management approaches use is called unidirectional data flow. So unidirectional data flow, and I've noticed that this is quite, it sort of takes on a different form depending on the framework that you're working on or the context that you're speaking in. So take this with a grain of salt. But unidirectional data flow to me is a design pattern for state management, right? And using this pattern, and it's not very complex too, but we'll see that in a minute. Using this pattern, you can make the flow of your data four main things to me. That's structured, consistent, predictable, and testable. So structured in a way that it's easy to know how things fit together within the state of your application. It's consistent because you can do the same sort of pattern everywhere. This is very dependent on the framework that you're using, but most of the time this is the case. It's predictable in a way that you know how to write every single part of it because it's so structured and consistent, and it's usually testable. Now that depends on the framework again and how you use it. You can write applications using Block and make it the most untestable thing ever, but it's going to be easier to test if you have sort of this pattern down. That's works in general, but I feel like a lot of frameworks that or a lot of sort of state management approaches that use unidirectional data flow really make this a great selling point. Now, as soon as you use that, you can help separate those views and your business logic. That's one of the main concerns here, right? So you can have separation of concerns that way. And especially, depending on the framework you use again, it works really well with declarative programming, especially what I'm going to show you right now. And that's what I really like about it. So let's take an example of an application where you just use the small sort of state management approach, right? So the classic sort of example, in this case, it's a counter example. And we're going to do no extra state management, whatever, just going to use whatever's in the framework and keep stateful. So keep your widget stateful, rather. So let's say that you have an application. This is your top level widget in your widget tree, right? That can be a material app. Now that material app will, in the counter example, generate a homepage. That homepage is stateful and it has a integer with a counter inside of it. Actually, the state does, not the widget itself, but whatever. So on the bottom right corner of that counter app is a button. And as soon as you press it, what it will do is it will increment the counter there. Now, this change won't show up yet on the screen because there's something else you need to do in order for this to show up in the UI. And usually I would have an audience and ask people, hey, what is that? And what method do you need to call here? But since we're using chat, it's a little bit hard for me to see, so I'm just going to give you the answer here. We need to call set state, right? As soon as you call set state, it will execute whatever method is inside of it and then trigger a rebuild on that stateful widget, right? So let's see this in the form of some code so we know what we're talking about. This is the default example, just pulled straight out of a Flutter repo. As soon as you create a new project, this is what you get. And then, so that's sort of the base widget of it. Then there's the home page, which is stateful. It creates that state that I talked about earlier. And then we get to this. Now, these are the important bits, right? So we have that integer there. We call set state whenever we want to increment that counter. And we pass that method over to the button. Right, so that's how it usually goes. Let's take this entire method and put it into let's take this entire functionality and put it into one method called increment counter, right? You put that in there. Cool. So that's fine. This is what the example shows. Now, my boss comes along and says like, oh, great work on the counter app, very unique. We want to have a second page where we display the same counter and we can increment it as well. And then you're like, okay, well, we need to work with different feature requests or whatever. Let's make a second page. And now it becomes interesting because we need to pass over that counter and the increment counter function both to our second page. Well, we can do that, right? Just construct a new widget and pass it around. And this is how you would do that, right? So just make a constructor that takes those, and then you can take those parameters in your second page, and then you're done. So cool. And so we have that link now, but we're sort of tied. We have that link set from the first homepage to the second, right? And that's okay, as long as sort of this flow is there, that we go from my homepage to my second page, we're totally fine. And then your boss comes along and says, we need tab navigation, and now your flow looks like this. And now you have a problem because that link that you made earlier won't work anymore, right? There's no way for us to, in a nice way, construct this from the home page to the second page, right? Because this is tab navigation, so we can navigate to either the home page or the second page from our app widget. That's going to be a problem. So what can we do to fix this? Well, first of all, we can throw that right out, the old link. And now we sort of need to take this counter and increment counter and lift it up. It's called lift state up. So we're going to need to lift that up into my app. So now that app is no longer stateless. It's now stateful because it needs to, keep track of that counter and increment counter function. Then you can pass it along. And I hope that I can convey that this is already a bit of a hassle. And this is just 2 pages. I mean, imagine if you had a whole bunch of pages, and most apps do. So what I'm trying to say is this doesn't scale well, right? And there's obviously methods and ways of doing this in a sort of better way than this simple example, but it gets the point across, I think. So what can we do to make this better? Well, use the state management approach. And in this case, I'm going to be talking about a couple that use unidirectional data flow. So within the context of Flutter, and this depends even what you're actually doing, because unidirectional data flow is a very general term to me. So unidirectional data flow in the context of Flutter and state management for me means this. To me, it means you have an immutable state that represents your app or a part of your app, right? So this can be sort of any sort of subsection or the state that's at the top of your app, whatever. Then we have a collection of events that represent actions. So this can be, for example, increment in our example just now, right? And then so we have actions in the form of event and then a state. Now, a reducer or a pure function is another part of this sort of framework architecture that will take a state and an event and produces a wholly new state, right? So we have a state with some data in it that we can display. And then we have an event that comes in that says increment this or do this, fetch this data or log in or log out, whatever. And then we have a reducer that is a pure function. So its only task is to take an event that it knows, take a state, and then produce a new state depending on that. So, for example, that could mean that we have a state, which is a number, a counter in this example, and an event that says increment. The pure function, the reducer, might take that state, the counter, the integer, and the event, and sees this event says increment counter. So I'm going to produce a new state, a new number, which is the old counter plus 1. That's sort of your bread and butter example of how such a flow would work. Now, this is sort of in a graph form how that would look like. So we have our state over there. That state, whatever it is you want to be, can be passed to our view that will render whatever state it gets. It doesn't need to know what to do with it necessarily, just that it gets a state and it needs to display it. That's it. Then that view has some button or an action somewhere, for example, like that button in the counter example. As soon as you press it, onPressed gets called, but this time it sends an event to the reducer. Now the reducer has the state or gets the state somehow, it depends on what you're using, and then end that event, and both of them together allow the reducer to produce a new state. And then that new state is then again passed to your view. So you can see this really nice sort of cycle going on of how your data flows through your app, right? The only thing that the view is concerned about is taking a state and showing it. And whenever there's an action, it needs to send that action off. But that's easy, right? In general, in this way, in the view, you only need to worry about the UI and not how am I going to manage the state within the UI. It also has a lot of nice pluses where if you can't modify something within the view without something else knowing about it in a certain way, right? Again, this depends on the framework that you're using, but usually the nice thing about this is, and that's also something that defines unidirectional data flow to me, is making sure that operations that happen on a state only allow it to happen in one way, right? So only the reducer can produce new states, right? And it's not the view that's going to mess with it, and then another component doesn't know about it. So now that old component is out of date. So now you need to call set state and all that. It's nice and concise, and it goes in a loop, and it's a very simple loop. So a couple packages that implement this fashion of state management. One is Redux, and this one is really popular from the JavaScript community. And right from the start, it's been ported to Dart by John Ryan and Brian Egan. And it works really well. There's a lot of people that use it. So yeah, good to them. I've used it in the past as well, but I've now sort of transitioned over fully to this other pattern called Bloc. And Bloc is made by Felix Angelov, right? One of my colleagues, I guess. And it's sort of like Redux to me. The API is very similar, but it allows for more easy access to asynchronous calls and handling asynchronous data and events and logging. So it has some very nice pluses that I'll go to in a bit. And then there's Cubit, what I like to call the little brother of Bloc. And this is sort of a smaller, more compact version almost of Bloc. That's not the real description, but that's how I view it. So there's two that I want to handle today, and that's Bloc and Cubit. I'm going to go over Bloc first. So first thing that you might wonder, what does it stand for? Business logic component, clever naming. And blocks are very much follow the pattern that we just described. So a block is a class containing a state and the reducers that allow to do something with that state. In a sense, it's nothing more than just a class, right? And it contains some variable, right? And it has some functions that can emit new states. Now, I said emit, and that's important because it uses the streams API. And what that allows us to do is make the building of UI that depends on a block very easy, because we have stuff like stream builders. So usually you use something called a block builder that would allow you to automatically rebuild a part of the UI as soon as that stream's value changes or that block state changes. So that has some really nice advantages. It also allows us to easily handle asynchronous data really well. So it has a lot of pluses going for it. Now, the block internally manages its own state, the state that's within it, and produces new states. But that's all internal. So your UI code doesn't need to know how a block or a business logic component is performing its logic and how it's producing new states. Your view or your UI only cares about if you get a new state, build it, and then dispatch an action as soon as something happens. That's all it needs to care about. Now, Bloc specifically consumes events in the form of classes. For every event that you want to trigger, you create a class for it. So you can make a base class that says, for example, counter event, and then you could have another class that extends that counter event that says counter plus button tapped or counter increment triggered, something like that. And then you can pass that event to your block, which is just an instance of that class. You can pass that to your block, and the block will go and figure out, which is what you write yourself, right? We'll go and figure out, okay, I have this state and this new increment event, what I'm going to do with it, emit a new state. Now, an example of constructing such a block is really rather simple. In this case, I'm going to use the block package because it makes life a lot easier. You can implement block in all these packages yourself, right? I mean, it's a small system in the end, but there's some really nice logic going on internally within the block package that I'd like to leverage. Now I import the block package, and then I'm going to create a new class with the counter block. It extends block, and then you first need to define what kind of event it's going to take. So I've made a separate abstract class called counter event, and then the state that it needs to hold. And this can be anything again, right? Integer, string, Boolean, class, whatever. So I'm, in this case, making a class called counter state that just contains an integer within it, and I'm passing that along. So now I have a counter block. It's really that simple. You need a couple other methods, but this goes a long way. I'm just going to take a sipper. Cool. So the way that I use blocks and qubits for that matter most often is per feature or screen. It's really nice to basically never have to deal with stateful widgets, except for some minor cases where it's really useful to have view specific state within some stateful widget instead of having to lift that up to your block. But everything as far as the state, as far as data and logic goes, that all lives in the block. And that can be its own little block for a certain screen or for an entire feature or just a global block, right? In most apps, you'll have a lot of blocks all over the place, right? Usually they're tied to a screen or to a certain feature. Now, these blocks can be passed around and retrieved using block providers that come with the Flutter block package. The Flutter block package in turn uses provider internally, which is a package made by Remi, who you're going to hear about in a little bit. So that's perfect. And so using those block providers, you can provide blocks from somewhere in your widget tree all the way down. And then another widget can retrieve that and build its UI depending on the state of that block. So let's sort of look at a visual example of what that looks like. Say that at the very top, you have a material app, right? Just like before. And then very high up in that widget tree, like right next to the material app, perhaps, you're going to have a block provider. This block provider in turn constructs a new counter block and then makes sure that anything below that widget, because block provider is just another widget, can access that counter block. That's the idea, right? So later you can say, can I get the counter block, my nearest counter block of this context? And then I will look up the nearest counter block, right? So then you can imagine that you have a whole string of widgets throughout your app. You can have some sort of scaffolding with an app bar or whatever, maybe a column or a list with some items. And then there's a piece of text somewhere where you need to access that counter block. Well, then you can either say, can I have the block provider of type counter block, which is nearest to me? That's totally fine. But a really nice way to do it in a sort of declarative fashion to me is to use a block builder. So you have your block provider at the top and then all these widgets in between. And then somewhere you have a block builder of type counter block. That will look up the nearest block provider that provides that counter block. And then as soon as you have that, you can build your view out of that state that you retrieve. And then every time that counter block gets updated with a new state that it emits internally, it will automatically rebuild that part of the UI for you. And that's really nice because now you don't have to think about, oh, I need to call set state and then subscribe to the block. And then I need to actually unsubscribe or cancel that subscription as soon as my state gets disposed of. So no hassle there. That's really nice about it. And then within that block builder, you can have all the widgets that you want that depend on that state, right? And then only the widgets that are inside that block builder will be triggered for a rebuild. That's the very nice thing about it. So you can really segment that, and then you'll have other widgets all the way down, right? Okay. Let's talk about Qubit, Block's little brother. I like Qubit, I really do. It's sort of to me, it's a sort of smaller or simpler form of what Block is doing. But it's actually sort of the other way around because all blocks are actually qubits. They used to live separately in separate packages, and then Felix actually combined them into one package, and blocks are just fancier qubits, so to speak. They're more fleshed out, and then they have a little bit more functionality, but that makes them more verbose. So qubits are actually the same concept, but they sort of execute it a little bit differently, although they share a lot of code between qubits and blocks internally, right? The reason that I think that qubits are nicer, like the main reason would be that qubits use public methods. that you can just access from that qubit instead of having to convey your actions through these event classes. And the nice thing about that is now for every action that I want to do, for every event, I don't need to create a separate class and pass that over to my block. I can just say, hey, take the qubit that's nearest, like the counter qubit, and call this function on it. That's a lot easier. Now it does come with some consequences where doing stuff like observing what methods are called on qubits is not really possible unless you call those methods yourself. And it really depends on what you need. But most of the times, qubits are perfectly fine, in my opinion. But there are reasons to use blocks instead. Okay, I hope that's all good. Now I wanted to take what we've talked about into action and actually show you how to work with qubits in a very small fashion. Right? There's a lot to learn still. So yeah, if you have any questions, I'll put links in the chat and I'll put them up in the talk repository later, so you can have a look. But yeah, I now wanted to sort of take this time to show you what I'm talking about and how to work with qubits specifically. So here we go. Ooh, chat's looking good. Hello, everyone. Okay. So what we have right here is a very simple application. This is just really the counter example, right? But I've edited a little bit. The main things that I've done here, and please chat, tell me if the text is not large enough. I'll see it and edit it, but I think it's fine. So I'll actually bump that up a couple bits though. There we go. Okay, good enough for me. So what we have right here is the counter example, but I've edited a little bit. The only thing that I've really done is added a couple dependencies here, mainly the block, equatable, and Flutter block packages, all which are going to come in handy in a little bit. I've added analysis options, so we have some nice analysis going on. I can never work without a linter because I make mistakes all the time. And then we have our example here. So this is it running live, and it's not really doing much at the moment, especially because I need to unlock my screen. There we go. So it's not really doing much, and that makes sense because there's no logic implemented actually at the moment. So what we're going to do is we're going to implement this counter block that I've been talking about. That plus button is not doing anything, and let's see what we have here. So we have our material app at the top. Then we construct a home page. That home page in turn has a scaffold with an app bar, and then a column with 2 pieces of text, right? One with the top one, and then ... which is what we're going to turn into a counter, hopefully. Then we have the floating action button at the bottom, and that has an onPressed callback, which can execute a function. And it currently doesn't do anything yet, but we're going to change that. So let me take another sip. Cool. So what I'm going to do first is construct or make the qubit that we're going to use for this particular feature. Now I can write them myself, and that's completely fine. And I could if I wanted to, but I'm actually going to use the extension that that Felix has made for Visual Studio Code, which is also available for IntelliJ and Android Studio, and that is the block extension, because that allows me to go over here to my lib folder. And then, oh, this is really tiny. Well, it says qubit, new qubit, right? So it can construct a new qubit for me, so I don't have to write the boilerplate myself. So I'm going to do that. Then I get to name it, and I'm just going to put in counter there. And then it says that it created the qubit. Perfect. So let's have a look at what we have here. We have the qubit itself and the state, just what I talked about before. Now with blocks, we would have events here as well. But again, we don't use classes for events now. We just use our regular old function calls. So I'm going to go into the qubit here, and this is it. It's extremely tiny, and that's also one thing that I like about it. That's the entire qubit, which is good. And then I'm going to go over to the state here. Now, the state looks a little bit more complex, but that's because just of how the boilerplate is set up. One nice thing of how Block and Qubit handle sort of their how would you say that? One pattern that I see a lot in Qubit and Block is that they like to the state is usually or some of the times a sort of type union between different sorts of states. And so one of them, this is a great example of that. So our counter state is abstract and has maybe some, generic fields that any old counter state can have. And then we have specific implementations of that counter state. So this is the initial state, and then we can have loading and, failure and whatever. So for our example, it's going to be really simple. So I'm actually going to remove that initial state and just make the counter state whatever we need it to be. Now, equatable is a package that allows us to define this props property here, and that allows us to easily determine if two instances of the counter state are the same. We don't need to overwrite the equals or the hash code or the equals operator. That's what I meant. And we can just provide those properties here, and then we'll compare them and then tell us if two objects are semantically equal or not. Also made by Felix. What a guy. I need my counter here. So I'm going to say final int counter. Now everything is going to complain. First off, I'm going to put the counter in the props. That will tell it that if the counters are equal, that means that two states are equal. And then I'm going to say this dot counter. So now we can actually put a counter in here. So that's our state. It's really tiny. That's cool. Then I'm going to go back over to our qubit, and now this doesn't exist anymore, so that's fine. I'm just going to say that our initial state that should be in the super call is going to be a counter state with initial counter 0. Makes sense to me. Now, we're almost done. The only thing that we need is a method for incrementing the counter. So I'm just going to say increment, and that's going to return void. Because that method itself is not going to return anything, but it will it can internally emit states, which is what we're going to see in a little bit. Okay, so now we have an increment method. I'm going to leave it empty for now. I'm going to go back to my main folder, and I'm going to add a little bit of logic here. So first off, we're going to need to have a way to, first off, we're going to need to construct one of these counter qubits, right? Because right now it's just a blueprint. So what I'm going to do is I'm going to add a block provider, and the block provider allows us to, as I said before, fetch our block or qubit, because their base class is the same, allows us to fetch a block or qubit from lower down in our widget tree. So how do I do that? Well, I could write it myself again, but I'm the lazy guy, so I'm just going to say wrap with block builder, which also comes from the extension. And then this is going to be counter block or counter qubit rather, and counter state. Now I just need to import both Flutter block and our counter qubit. And then, oh, right, this thing isn't const anymore. That's a pity. So our builder is, oh, wait, no, I'm making a huge mistake. Apologies about that. I need a block provider. What am I doing? I'm going to wrap it with a block provider. There we go. That looks better. So the block provider has two properties. One is its child, the thing it needs to render. So whatever comes below it in the widget tree. And then the block or the qubit that it needs to provide. In this case, it's going to be our counter block. Qubit again. Love the naming. And then this isn't const anymore. And we need to import it. So we can make the homepage still const for a little bit of performance. And that's it. So now, as soon as this material app is being built for the first time, it's going to construct that counter qubit as soon as it's needed, and then construct a homepage. So it's a very functional widget. You don't actually see this on the screen, right? So now, anywhere below that point in our app, we can reach that qubit, which is great. So I'm going to go over to here, and it seems like this piece of text could use some data. So I'm going to wrap this in a block builder this time. And that's going to also take in the counter qubit. So we're saying this is a block builder, and it needs to look for the nearest counter qubit that's being provided by a block provider. That counter qubit needs to contain a counter state, and this is the thing that we're going to build every time that that the state changes, right? And at this point, we're almost done. I mean, at this point, from line 51, we have access to that counter state. Now we just need to show it. So I'm going to use some nice string interpolation here and say state.counter. Perfect. It's all type safe. That's good. And so now this will render our counter. Perfect. Let's see what happens. That's 0. Nice, nice, nice. Okay. And this does nothing yet, but that's just a couple clicks away. Because what do we need to do as soon as we press the button? Well, we need to look up the counter qubit that's being passed from up top. So I'm going to say block provider dot of type. I'm not actually sure if the type definition needs to be here. Yeah, it can be. So in oh, it's been changed, hasn't it? Okay, I'm going to use the cool kids way. So Dart has extension methods, right? And they're really useful if you use them properly and with care. One of the best things about extension methods is this trick. So I've imported Flutter block, which means that it comes with extension methods that I can use. So now, instead of doing block provider of or looking it up or whatever, I can just say, oh, I already realized what I did wrong there. But anyway, I can just say context.block, a block of type counter qubit. And there we go. That's it. So now this will retrieve the nearest counter qubit for me. And then I can say dot and then increment. There we go. That's it. The only thing we need to do now is actually increment the counter. But this method will still, it will execute, right? I can put a print statement here and say that this is proof. Save that. There we go. You can see it. It's tiny, but it's there. Trust me. So now the last thing we need to do is actually increment that state. So, or emit a new state with an incremented counter. So as soon as we need to increment, first thing we do is say that the old counter is equal to the state counter. That's our current counter. The new counter is going to take in, it's going to be the old counter plus 1, right? So our new state will be a counter state, so new state with our new counter. And then final thing is I'm going to emit that new state, right? We're talking about, it's very streams focused, sort of stream API, right? So we can emit a new state. This increment method doesn't return a new state or something, right? It can emit a new state. And in fact, it can emit multiple new states, which is great. I'll talk about that in a little bit. So we take the old counter, which is the current one, increment it. That's going to be our new counter, make a new state, emit that. Save, reload. There we go. Easy as that. So this is great. I can't help myself. I'm gonna make this a one-liner because this is just state.counter plus 1. And there we go. Now this is a nice one-liner. And it will work the exact same. There we go. So that's it really. And so nice thing again about having to emit states is that you can do this asynchronously. So you can imagine that you emit a state where you're loading something, right? And then you're gonna fetch some data asynchronously somewhere. And then as soon as that data is loaded, then you can emit a new state, a loaded state, with that data. That's a very popular example of what you can do with sort of having this separation between calling a method, so making an action, and actually getting data back. And yeah, I think that's it. That's a very basic overview of how you can use qubits. And now this can grow and scale almost indefinitely, right? So as long as you keep your qubits small and your blocks small, then you're good to go. So that's all I have to say about that. I'd love to answer some questions later, but really that's it for me for this talk and for Qubit. Make sure to go to blocklibrary.dev to learn more about both Block and Qubit. You can visit all my talks on Cutley/JFK Talks, and additionally, all the code that I just showed, including documentation, you can also find there. So if you want to have a nice little read of everything that I explained there, you can read that. There's notes, there's a PDF version of the slides, and my email is in there probably. Well, there's my Twitter, so you can just find me on there if you want to. And that's really it for me. Within time, I think.
Hey, thanks for this well-structured talk. It was really great, in my opinion, if you ask me, and it introduced the concept very well. So I think we had like 2 questions, or maybe 3. The first one was about equitable. If you could explain this again, but I think that this was explained in the chat by someone else.
Yeah, I see it. Yeah, supposedly Sam gave a very good explanation there. I can talk about it a little bit if you want to.
Yeah, why not?
So usually, if you have a certain class and you say equals another class, it won't check for equality based on what properties they have internally. Instead, it will look if the memory addresses are the same, right? Which most of the time is not what you want. You want to actually check whether 2 classes contain the same fields and if they are semantically the same. And so you can do that by overriding the equals operator, the double equals operator, and the hash code. That's the regular way of doing it. But I like the package equatable because I just need to tell the properties, that props property, what my class consists of, what properties it has, and then it will internally, as soon as I do equals, check if they are the same. What this also brings us is that if Qubit notices, or Block for that matter, notices that I emit 2 states that are the exact same, it won't emit 2 states. It will actually only emit 1, so that your UI will only rebuild once. So if you emit the same state 100 times in a row, it will only rebuild once because it knows that there's no change between the last and the current state. So that's a really nice optimization that you can do.
Yeah, that's great. And then I think the next question was like in the same direction. Is it useful for Bloc Qubit internals? In other words, is there any performance optimization if you use it? So that's what you just answered, actually, I think.
Yeah, there is. And for devs, it's really nice because I just need to define the properties. I just have to not forget to put all the properties in there because then you get into weird issues. But yeah, it's really great. I use it everywhere, even without Block. Just using it for models, awesome.
Nice. Then we have, does the way in which Flutter is built, reactive or declarative, accommodate unidirectional state manage approaches over MVVM, MVC?
That's difficult to me because that really depends on what sort of state management pattern you use, I think. And I haven't worked with MVVM, MVC directly, although I think there's a lot of overlap between all these sorts of frameworks. So my answer is I'm not sure. The only thing that I do know is that with all the unidirectional state management patterns that I've worked with Flutter and React for that matter, the declarative nature of using a block provider, which is just a widget, and a block builder, which is just another widget, makes it really readable and easy to go through when reading the code and writing it too. So I really like the way that it accommodates that declarative type of programming.
Thank you very much. I think that's all.
Cool. No problem.
I can just repeat myself. This was a great talk, and I think the audience thinks so too. Happy to have.
Thank you, man.
Happy that
Thanks for having me.
Joining today. Yeah, thanks.
Sure.
Okay, then our next speaker is Remi, and he's also demonstrating you his new library or his package Riverpod, which also uses unidirectional data flow internally. Remi, can you hear me?
Yeah, I can. Can you hear me?
Cool. So I'd like to introduce you to the audience also in a few sentences. You actually contributed on Stackoverflow. That's what I realized the most. That's this Stackoverflow thing. When I announced the meetup, you already had an impressive score of 118,000 points on Stackoverflow. When I checked it again yesterday, it was already 124,000 and a bit more. So you achieved 4 weeks what I achieved in the last maybe 3-4 years. So the first thing I have to do is thank you for the individual support you give to each one of us. So because it means you answer lots of questions, you have the community each and every day coming forth and doing their everyday work, and also, yeah. And it's not the only thing you do. You also are maintainer of several Flutter packages. Could you highlight the project which you are most proud of? I guess also provider is a part of it, but are there also others you would like to mention here?
Yeah, I quite like my package called Freezed, which is a code generator to generate kind of like data classes in Dart and union types, which I think is a very lacking feature in Dart, and that many people want. And this didn't manage to is quite simple, I think. So I really like it.
Cool. I think we are experiencing a bit like a bad connection here. So I hope this goes well during the talk. But let's just simply jump into it. I'll just hand over the stage to you. Thanks for your talk about Riverpod.
So can you see my screen? Yeah, it's a PS like, yes. Okay, so today I want to talk to you a bit about one project of mine, which is named Riverpod, as you can see, which is kind of a rewrite of Provider, in the sense that it tries to fix different issues with Provider and makes things better overall. So yeah, we're basically going to talk about state management tonight. And you may be wondering why we have yet another talk about state management, but because like we have talked about state management literally all the time, and so many packages coming out every week now, I think. But so what I want to do first is, before talking directly about Riverpod and why it's useful, I want to talk about state management more in general and why we want to use packages for state management in general, and what we can do to what they can do to improve our applications. And so, yeah, one of the main reasons basically is, yeah, state management may look simple, but it's actually not as simple as you may think. And taking deeper look is definitely something. So yeah. So let's do some little story. We want to make an application for our business. So whatever that want, I would say, like you want your company to make more money. You want to decrease the cost of maintaining the application, and you also want to make sure that your application is successful in the sense that if you develop a new feature, you want to make sure that it's actually useful for the users and it will bring more money. So you know a lot what influence how you get money in general. Like lottery, for example, can bring a lot of benefits, but has such a big risk that it's not necessarily worth it. So we have three main goals, I would say. And then we have a few ways to influence these goals. So first, yeah, we have the cost. And by that, I mean the development cost. So that's the salary of your team members, the licenses of the project you're building, much of things like this. Then you can have the development speed of the project. So how long does it take to develop a new feature? So if it develops, if it takes 2 weeks to make a counter, if it takes 2 weeks to make something, it will likely cost more than if it took 1 week to make the same thing. We also have maintainability, which is kind of a representation on how you are able to preserve your productivity for making applications over time. So it's not an immediate benefit, it's more about the long-term benefit. We kind of have another one that I like to call flexibility, which is about having many doors open. So like when you're building a new feature, you don't really know what comes next. So making a flexible architecture is making sure that when the users want a new feature, you can develop that feature. You didn't close the door before, and you can actually do it. And finally, we have the code quality, not necessarily just the code itself, the product quality. So it can be like user experience. It can be how many bugs there are in the application, or it's using fancy animations, or things like this in general. It can be a very broad topic. The thing is, we would usually prefer to have everything maxed out, so very cheap, very good quality, flexible, maintainable. But that's not really possible. Let's be honest. You have to make trade-offs. So what happens is when you try to increase one variable, you will likely decrease other variables. So you have to kind of decide what you want to focus on at that time. Like, for example, you may want to increase the productivity of your team when making a new feature. So you have a few possibilities. For example, you could scale your team by hiring new members. But then, of course, it will increase the cost of making your maintaining your application. You can also try and like improve your architecture, which is usually done with state management, which we'll talk a little bit later. But that's usually very difficult to improve on and could be kind of like a high risk, high reward bet where if you don't do architecture correctly, you could like not win anything or even worse, lose money. Yeah. So yeah, it's really a trade-off about what you want to improve on. And so state management is really the same idea about not necessarily should I hire a new team member, but more about should I use this design partner or things like this. So will it make the application more maintainable but reduce the development speed, things like this. So for example, we kind of have like two big archetypes when dealing with state management. We can talk about the extreme in the flexibility, which is usually JavaScript or any untyped language, where you may use mutable global variables to do whatever you want. So the basic idea is it's super flexible. That's very used code and executed at runtime. Evaluate strings, average code from a string, do very fancy stuff thanks to the flexibility of these tools. So yeah, in the end, it tends to have like also less boilerplate because you can do basically everything. So you can almost all the time find ways to shortcut how to do things to make it in less code. And it also, the way it's usually used is it doesn't require a lot of knowledge when starting. So you can start with just knowing how to declare a variable and how to make an if or a while. And you can get pretty far with this. The code may not be very pretty, but you can get things done, even if you have to refactor in the future, which is great. The issue is the fact that we can do everything is both a benefit and a downside. Like we can do both very, very good things. We can also do very, very bad things. Come and bite you later in the future. You will definitely have bugs that you missed, or that you definitely missed, or regressions all the time. Even with good testing, it's difficult to catch all the potential issues when having a large code base. And also, one of the things I kind of dislike with this thing is it looks very simple at first, but in my opinion, it's not actually simple. It's kind of tricking you in the sense that the code, you have to write less code and you have to learn less things. So it seems simple, but in the end, if you want to do things properly, if you want to have a maintainable code, there are so many extra layers of things you need to be aware of, like design patterns, what you should and should not do, and you need to do a lot of trials and errors to get things right, which is something we tend to usually forget. So it tricks a lot of newcomers into thinking that it's very simple, but it's not. Then we have kind of the complete opposite, where you can go like full functional programming with maybe L, maybe Haskell, whatever you want. That's like the complete opposite of what we mentioned before, where everything is very, very structured, and to the point where it's almost boring to write the code because everything's already pre-designed for you. You know where you need to place your function, what you need to write inside the function, and you don't really have much choice. So it's very good in the sense that when you move your code, when you're using static types or union types, when you're using immutable data, things like this, all of these toolings that makes things more structured will make sure that when you develop your application, it's more maintainable, it's more predictable in the sense that, like for example, if you have a function with immutable data, you know that from the beginning to the end of the function, the value of your variable didn't change, which sounds kind of stupid when you hear about it. Like, why would it change? But when your application grows over time, you may not realize that when changing a tiny function somewhere, that this function actually is used by other things somewhere. So if you like change some variables inside this tiny function, it may have big impacts on the other functions that use it. So the fact that everything is immutable, everything is typed, and everything like this ensures that you don't have these issues. And another cool benefits with like static types, immutability, and everything is that it makes the tooling very, very, very powerful because everything is basically statically analyzable. So like I've seen recently something called state machines, where the dev tool is able to generate a very advanced graph about all the interactions between your states. So it's able to know both what is inside your state, but how things are modified. So it knows how to increment the value and everything, and it generates a very beautiful graph. And it's very difficult to get this state management wrong when you're using functional programming in general, for example, because you don't really have the choice, like I mentioned. So since you don't really have the choice, you can't. You have very little room to make mistakes, and you can easily refactor to get things right later in the future if you want to. Whereas with global data, it's very difficult to refactor. The issue is it looks very, very scary. Like one of the big issues with functional programming, I would say, is it uses fancy names for everything. And so these names are too advanced, I think, and so they scare people off. So like monad, everybody heard about monad and everybody's scared about monads, but usually you don't really have to be scared about it. It's just a function in the end. And so yeah, there is this tendency also in I think in some technologies resolving around this to kind of over-engineer things, where you're restricting yourself just for the point of restricting yourself. And yeah, okay, let's continue. So both sides have their benefits and their downsides. So there's no really there are no really universal solutions to state management. You can't really say immutable data is better, mutable data is better. It depends on the context. And so that's something you need to be aware of. I would say that usually you can start with immutable data because it's more predictable, and you can slowly refactor some to mutability if you need to. But that doesn't mean you have to stick with one approach over time. And so one of the things I really think is important is refactoring, because one of the key points that we rarely mention when making applications is that, sure, we can make a feature, but the code base change over time. The needs for the applications change over time. Like maybe suddenly tomorrow your product owner will ask you to implement undo redo on your application. And so if you didn't prepare for that, you will be taken aback, and you won't know how to implement undo redo easily if you didn't prepare for it. You will definitely need to like do some refactoring over time to adapt to what is the most ideal solution at that time. So you need to keep in mind that your code need to be easily changeable to adapt to new features. So refactoring is one of the main reasons why I started this project called Riverpod, because one of the main downsides with Provider is that it's not compile safe. What that means is like when you try to read a provider from Provider, there's no actual guarantee that the provider you're reading exists. So you need to actually run your code to know if it's working or not. So it works fine for small applications, but when you have like dozens, if not hundreds of pages, it's very difficult to know if you didn't miss one edge case. Even with good testing, it can be difficult to find all the cases. Like for example, you may have refactored a provider to be asynchronously loaded instead of synchronously loaded, which means that maybe when you tested your code, it worked when you tested it because it was already prefetched, because you came to this page from another page that already preloaded the data. But what you didn't know is that if you came to the same page from another place, the data may not be preloaded, but the widget that's using the data is not supporting this scenario where there may be an error or a loading state for this provider after the refactoring. And by default, when you're using like context.watch or provider of in Provider, you won't be able to know if you handled all the cases or made all the changes necessary when you modify your provider. And a common limitation too is like people have complained to me all the time about like, we want a stream proxy provider, we want Like I want to combine providers, like asynchronous providers and synchronous providers. I want to do fancy stuff. I want to have multiple providers of the same types. And we can't really do this in provider because of how innovative widgets work. So it's a very frustrating thing to have people request for new features, but when I know that I can't do anything with the way inherited widgets work. So with the Riverpod, I try to fix these issues, like making sure that everything is compile safe, making sure that we fix this common request for features. So yeah, if you want to take like, I won't list all of them, but that's this list is basically a small condensed list of the different points that I focused on with Riverpod. So maybe just take one of them, which is like testability. I think it's very important for code to be testable, and so Riverpod makes sure that every code you write with Riverpod is testable. Even if you do fancy stuff, it will still be testable, and it makes sure that the code is readable. So yeah. If you want to learn more about the reasoning on why I made a new package, I also made a talk previously, which is kind of outdated in the syntax, but the reasoning behind why I made a Riverpod are the same. So you can definitely watch it to see all the different points I listed previously. So yeah, back to Riverpod. Yeah, so if you want to talk about Riverpod, I think like one of them, there are multiple benefits with Riverpod. Like first point, one of them is DevTool integration. So this is a screenshot that is taken from Riverpod application, where you can see the state of your application with Riverpod. You could do the same with provider. But at the same time, it's good to know that I'm also working on a full-blown DevTool for Riverpod to like not only visualize the state but also edit it inside the DevTool. Yeah. So for then instead of like explaining how Riverpod works directly, I think it's a good thing to do would be like go through step by steps how to do like common features in Riverpod. So I suggest that we start with making the typical counter application, because everybody wants to make control applications apparently. So let's make one. So step one. The first thing you need to do in Riverpod when installing the package, right after installing the package, is you go to your main file and you add a widget named provider scope to your main right above your my widget. You don't really have to care about what this widget does. Just this thing, you just need to know that this widget is what enables Riverpod to work. So just add this widget and forget about it. You don't have to come back to this widget in the future, unless you want to do testing. This is a different topic. Yeah. The second step would be to we will start with declaring some state. So the easiest way to declare state in Riverpod is to use state provider. State provider is kind of a simple variable. So the syntax for declaring a state provider and any other providers in Riverpod is just you declare a global variable. It's not really global, but you declare a global variable in provider. You declare a global variable in your application that is immutable. So with the final keyword, you assign it your state provider instance, which takes the generic type of the value you want to create. So here it's an integer for the counter. Then the syntax is that it takes a function which receives one parameter called ref, which we'll talk about later. Then the next step would be to just return the initial value. So here just 0 for our counter. So here it says we've already created our state provider with the counter. From here, we can try and read the counter inside our widget tree. So the way this would work in Riverpod would be to use consumer widget. Consumer widget, you can think of it as kind of like a stateless widget with extra features. It's a stateless widget that is also able to read providers. So you don't have it to extend stateless widget, but instead consumer widget, and it adds this new variable to your bid method, which allows you to read providers. So once you've created your consumer widget, you can then add this line using the new parameter passed to your build method to read the provider of your choice. So here we are using watch, and we are passing the counter providers that we created previously. And then we're just reading the current state. And so just by doing this line, our home widget is suddenly listening to the counter state. So if we ever in the future change the state of the counter, this will automatically rebuild the home application. So then we can just return a scaffold and with a text to render the text as we would usually do. So here at this step, it would just render 0 and do nothing else. Finally, what we need to do is to add a floating button action. So that floating button action will be used to increment the state of the provider. So we first just use the typical syntax floating button action, and we pass it an icon, nothing special here. But then we are inside the onPress callback. We are using this context.read function, which allows us to read a provider, and then we are reading the provider without subscribing to the provider. So here it doesn't really matter, because in the same way that we are already subscribed to this provider, but we may have just a button that doesn't really care about what's the state of the application, what's the state of the provider, that just want to read it to modify it. So here we are using context.read counter. And then now that we have the counter instance, we can increment it simply. And so the act of incrementing the state variables will be enough to automatically notify home that it needs to be rebuilt. And then our UI will update with the new counter. We don't have to call notify listeners or whatever. It already works by default. Yeah. So that's it for a counter. So then we can start with a simple login page. We're using the same principles that we saw previously about creating the providers and reading them. And we'll go slightly further. So first, we can declare 2 providers. So we can start with a login provider for the username or the email or whatever. Then a password provider to store the password of the user, which are once again state providers. But instead of using integers, we're using strings. Yeah. Then we can create a form. So here's just a simple column with 2 text fields, where when the value change on the text field, it updates the associated provider. So when you're typing on the login field, it updates the state provider that stores the login state. And we are updating the password. It also does the same thing with the state provider for the password. Yeah. The next step would be to add a raise button. This raise button would be used to submit the form. So first, we just add a simple raise button, which does nothing. And one of the first things we may want to do would be to handle some validation on the form before handling the content of the raise button. So what we want to do would be to disable the raise button when we didn't provide both username and a password. So what we could do would, an easy way to do that would be to listen to both the state of the login and the state of the password inside the widget, and then make a Boolean based on both of these strings, such that if there is both a username and a password, then we can type, then we can submit the form. If not, then we can't. But one thing you need to be very careful of with this one is that the refresh rate of the state of the password or the login is much higher than the refresh rate of whether you can submit the form or not. Because in the end, you may type a lot in your input in your login field without ever typing a password. So if you're listening directly to the login inside your widget, this will cause the widget to rebuild every time the content of the text fields update, even if the can login variable didn't change in the end because the password is not filled. So that would cause some unnecessary rebuilds of your form for a reason, because we only care about when the can login state change. So that's not very efficient. What we want to do, we want to filter rebuilds where we want to rebuild the widget only when the can login state changes. So one easy way to do that would be to extract this logic that we had previously out of the form widget inside a custom provider, which expose only the can login variable. So here, what we do is we're creating a new provider, and here it's just return a Boolean. We are using a simple provider. We're not using state provider because we don't actually care about changing the variable manually. It's just controlled by all the other external variables. And so the state of this provider will actually be the combination of the other providers. So to do that, we can use the ref parameter that is passed to our provider that we saw previously. So using this ref object, we can call the watch method that is equivalent to the watch method of consumer widget, which will make the provider listen to the provider of your choice. So here, the can login provider is listening to the login provider and the password provider, such that whenever either the login or the password updates, then the can login state may update. But the interesting part about this is that we've extracted the state of the can login variable in a different provider. So while the computation may re-update at some point, so whenever you type on your keyboard, whether we can log in or not will be recomputed. But the login widget will actually not update. Like the login widget, when it's listening to the can login provider, will only rebuild if the result of the can login provider updates. So if we're typing only in the login input without filling a password, it won't rebuild the widget for no reason, which is a lot more efficient. And so you can think of this architecture as kind of an implicit graph where you have your login provider and your password provider, and then they are both combined into a can login provider, which filters the rebuilds, which filters the updates if there is nothing that changed when either of the dependency change. And then the UI just consumes the can login provider. And so you have this unidirectional data flow that Jay mentioned previously, where the data is just passed down, and the can login cannot modify the login provider, for example. And so finally, the last step for our login form would be to expose the user ID after login. So for this, we could create a third provider, which stores the token for the user ID. And then we could, inside the on-click of our raise button, like potentially use Google authentication for a base, I don't know, pass it the login and the password, and then as a result obtain a user ID. And then once we have this user ID, we can send it to the user ID provider such that our UI that needs authentication will be able to use the user ID provider. And finally, we can redirect to another route that needs authentication, like the home page, for example. A third example would be the infinite list. So like you have an infinite list of information. So here I have this screenshot is a clone of Stackoverflow that I implemented, which you can see in the Riverpod repository. Yeah. So a straightforward way to implement pagination with Riverpod would be to use something called feature provider combined with family. So the basic idea of feature provider is that it's a provider that asynchronously creates a value. So it's like potentially fetching some data from a server. And then the family constructor adds extra parameters, extra external parameters to the provider. So if you didn't specify the family, you wouldn't be able to obtain the page index for your query. So you would only be able to maybe fetch the first page, which is not very useful. So by using a feature provider combined with family, we are able to both asynchronously obtain the page and also have a result that vary depending on the page that you're trying to obtain. So here the syntax is feature provider.family. We specify the return type, so it's an instance of the page object. And then we specify the parameter. So here it's just an integer for the page index. Then the implementation would be like your typical way of fetching some data from an API, from a REST API. So you're having a maybe DIO or maybe an HTTP client in your calling like dio.get, your pass. Then you're passing the page index parameters that we received previously from the function parameter. And then we are decoding the JSON using maybe JSON serial or build value or phrase, whatever you want. So yeah, that's your typical way of fetching things. So at this stage, we could already like inside our UI display the first page. The way we could do that would be to use, once again, the watch function from consumer widget we talked previously. So, but there is a twist. The difference is that before we just passed the provider without any extra steps. But here we created our provider with the family keyword we mentioned previously. So we need to pass an extra parameter to the provider. So we need to pass the page index. So here we're just trying to read the first page, so we're passing 0. So what this does is that it's listening to the first page and it's fetching the first page, and the other pages are not fetched. And then we obtain an object allows us to listen to the state of the request made by future provider, because since the page fetching is asynchronous, then we need to handle the error and loading state. So one clean way to do that using Riverpod when using future provider is to use the .when function. So with using the .when function, you can do kind of like a switch case over the loading state, the error state, and the data state, where in each state, in each step, you receive the proper parameter. So like in the error state, you receive the error in the stack trace. And so in the data status, you will be able to like maybe show a list view and iterate over the different items to show the item. But here we're just showing the first page, so it's not very interesting. We want to show all the pages. So an extra step is to obtain the total number of items, because ListView, when we are using ListView, it asks us for that item count parameter. So we need to provide this item count parameter to ListView so that it has a limit when scrolling. It doesn't just scroll to the end of the word. So usually when you're dealing with REST APIs, the pagination API in the response, it not only gives you the items, it also gives you the total item count. So here, to obtain the total number of pages, what we're doing is we're creating an extra provider, which will just listen to the first page, and then from the first page, it will retrieve the total count parameter and expose that directly. So then our UI is able to read the total count of items and listen just to the item count, which we are then able to pass to ListView.builder. And then finally, now that we have a way to fetch pages and a way to obtain the total number of items, we can create all the items individually. So we can show all the pages. So this is done directly inside Item Builder. So what we would typically do would be to create a first, inside our Item Builder, we will create a consumer widget to retrieve these wash parameters that we need to listen to providers. So now that we have this wash parameter, we can use it to listen to the page based on the index passed to Item Builder. So here there is a slight difference between the page and the item index. So like your page may contain like 50 items, and so your index may be 50, but the page you need to request is the first page. So we are using the current index divided by the item limit to obtain the page that we want to request. So here we are obtaining the page based on the index. And then we can iterate over the loading states like we mentioned previously. So the same thing, loading our data. And finally, now that we have the page, we can obtain the item from the index by using modulo to obtain the proper item inside the page. So here, with just this code, we are suddenly able to have this infinite list views that automatically load as you scroll without doing much. It's the logic is more UI than actual state management in the end. In the end, the state management, we just created the feature provider, and the fetching is done almost autonomously. And one interesting benefit is that we can very easily implement pull to refresh using this architecture too. Like in a few lines of code, we can add this functionality. So an easy way. So a first step to implement the pull to refresh functionality would be to first add a way to refresh all the pages at once. So here you can just look at this code that I will explain slightly later. The basic idea is that we need to bind all the pages to a common ancestor provider, such that when we refresh the common ancestor provider, this will refresh all the pages at once. So this is done just first by creating an empty provider that doesn't return anything, and then we're washing the provider inside the future providers that we created previously. So what this does in the end is that it updates the graph of states that I mentioned previously. So in the end, the graph of states that we have using this architecture, we would have as a very root our page group provider. Then using family, we have multiple branches depending on the page index. So the first page has its own state, the second page has its own state. And then each page has numerous items. So we have this exploded view, very, very linear too. And so the idea is that when we, since Riverpod is using unidirectional data flow, what you could do is refresh page group, which is the very root of this graph. And since everything else is depending on it, from the page to the items, then refreshing page group will automatically refresh every descendant too. Which means that to implement the refresh indicator, in the end, the only thing you need to do is you wrap your list view inside refresh indicator, and then you call this function named context.refresh, and then you pass the page group provider that we created previously, which is at the top of our graph, which automatically will invalidate the state of all the pages. And then to make sure that the spinners renders correctly when pulling the refresh indicator, we obtain the future for the first page to make sure that the spinner continues to spin until the first page finishes to load. And then an REI automatically refresh as we do a pull to refresh. So yeah, we've practically done all the example I wanted to show you. So a few key takeaways from this talk. Like there are a few interesting things to notice. That first, you may have noticed that you don't have to declare providers inside the widget tree anymore. Like one of the common complaints with provider was that we are kind of mixing state business logic and UI logic, whereas here all the providers are extracted from the widget tree. So like the pagination we implemented with video provider is completely independent from how our UI worked. And so we can test it independently and everything. Then we can declare as many providers of the as we want. And we also don't have conflicts on the same types. So we can declare it, we can have multiple providers of the same types without conflicts that we would normally not be able to do in provider. Another interesting point too is that there is no nesting required to listen to multiple providers. Like one of my complaints with builders is that it tends to get very, very nested as soon as you want to listen to more things. So you lose a lot of heritability. Whereas with Riverpod, you can just chain function call linearly. So it's suddenly a lot more readable what you're trying to do. Yeah, it's the same one. We can try to, we also can try to read providers that don't exist, because now the syntax to read a provider is relying on the provider variable, which means that if we didn't create this provider variable, then we cannot read the provider. The code won't compile. So you cannot read a provider that you cannot access anymore, which makes refactoring a lot easier. So like if you remove the provider, suddenly everything that uses this provider will not compile anymore. In the same fashion, like if you somehow refactored your counter from an integer to a double, you don't need to update every single context watch integer to context watch double, which could be very error prone. With this syntax of using context, with using watch my provider, it automatically knows what's the type of the value obtained. So we don't need to resort to such trick. So we also have this unidirectional graph that we mentioned, which helps us with refreshing things or improving performances on some cases. And yeah, we have these advanced features like regression, paginations out of the box. And yeah, that's basically it for my description of Riverpod, I guess. So if you have any question, feel free to ask me.
Hey, thanks, Remi, for this detailed talk about Riverpod. I don't see any questions in the chat so far, but maybe someone still wants to post any question here. So I'll give you like a few seconds.
It doesn't have to be specific to a provider, by the way, if you want to ask any question.
Okay. Any questions to Remi? Great job. Yeah. I guess currently no questions. So I'd like to wrap up a bit here this event. Thanks again to our speakers, who really why name Riverpod? Maybe that's a good question.
It's an anagram of provider. It's using the same letters but in a different order, and there is also a secondary meaning where, like, in Dart we have these streams all the time, and so using river in the name kind of remind us of streams in general, because it's basically in the same team where you are having this flow of data that updates over time. So it's very similar to streams in some way. And so having river in the name sounded interesting.
Okay, then supposedly Sam also had 2 questions. There is one, yeah, also it is recommended to store these state variables inside a class, or is it okay to put them in a file and declare them globally?
It's okay to put them in a file and declare them globally. You don't even have to put them in the same file. You can place them kind of everywhere you want. That may sound scary at first, but one of the things that you should be aware of is that we don't really have the same downside as using global variables. Like when using global variables, the issues with global variables are you can modify your state everywhere at all the time, which is not actually the case with providers. Like I mentioned previously, with providers, we have this unidirectional graph of states. And so since it's a unidirectional graph of states, that implicitly means we cannot update things anywhere as we want to. So we don't have the downside of spaghetti code, I would say. And then the other point is, I don't remember what the other point is, sorry. I wanted to mention one, but yeah, testing. The other downside usually with global variables is that they are not testable. But with providers, I didn't really mention it inside this one because it would be too much, but every providers can be mocked or replaced with a different behavior during tests. So like if you, for example, you add your future provider during your unit tests, you may want to mark the result to have a specific behavior inside your test to make sure you're testing the error cases and it's everything. And so with providers, you will be able to easily do that. There is a guide on the documentation that explains you how to do that.
All right, thanks for this answer. Okay, I think that's it. So great talks tonight, or wherever you are, depending on the time you have. Here it's night now. Thanks again for that. Jay provided his talk, and you'll be able to find the link to his talk in the chat in a few minutes. Then I also like to thank to the people who are backstage here, which is Lucas, the co-organizer of this meetup here today, who managed the whole technical stuff. And it wouldn't be possible just for one person to host this thing like that. Also, Marco, the other co-organizer of the meetup, helped us a lot in the before this event. And last but not least, the community. Thanks a lot for watching today, for being such a great audience. And I hope to see you again in one of our next meetups. Just follow us on Twitter or join our meetup group, or head over to gdgcommunity.dev. Hope to see you again. Bye.
Bye.